Welcome to This Explainer. Today, we're doing something really fun. We're peeling back the visual layers of the web to understand the invisible logic that powers the applications we use every single day. Look, we all know what a website looks like on the surface, but today we're figuring out exactly how it thinks. To get started, I want you to picture two completely different online bookstores. Scenario A is, well, it's basic. It relies entirely on static HTML pages for its inventory. If a book runs out of stock, an actual administrator has to go in and manually edit the page to tell you. If you want to buy something, you literally have to send an email, and the payment happens completely offline. Now compare that to scenario B. It's fully automated. You're getting real-time stock status, automated checkout, and direct, secure online payments perfectly integrated right into the interface. So ask yourself, which of these is a true web app? And honestly, more importantly, what exact functional blueprint makes all of that dynamic automation in scenario B actually possible? To answer that, today's explainer is going to map out the journey. We'll start by looking beyond the visual interface. Check out web app functionality in action. Unpack the functional architecture blueprint, demystify MVC architecture, and finally, map out system states. Let's jump right in. Section 1. Beyond the visual interface. In the early days of the web, things were, let's be honest, incredibly simple. Early web apps were mostly just about basic info management, delivering static content through simple HTML. But then, later web apps completely changed the game. By introducing client and server-side scripting, along with really rich interactions, the web became highly task-oriented. And that right there is the absolute heart of functional design. It's not about choosing the right color palette. It's about defining core capabilities, features, and exactly how the app is going to support the user's tasks. Section 2. Web app functionality in action. Take Google Maps, for instance. This is an absolute masterclass in client-side interaction support. It uses drop-down menus, zooming, and scrolling to let you manipulate data right there in your browser. It manages all of this client-side information access incredibly smoothly, and it does it without needing to reload the entire page from the server every single time you drag the map an inch to the left. Or consider Wimbledon's live match reports. This is a perfect example of functionality that was designed specifically to handle and push dynamic, rapidly changing content. As a match happens, those scores are updating in real time. The system has to manage that continuous influx of live data and push it out instantly to the users. And then, of course, we have the giant, Amazon. When you hit checkout on Amazon, you're experiencing some seriously complex workflow process support. Behind that simple screen, the app is handling the secure management of massive datasets. It's checking inventory, processing your payment credentials, and managing shipping logistics, literally all at once. Section 3. The functional architecture blueprint. Functional architecture essentially acts as a highly detailed map for the application's domain. And to build it, we have to answer two vital questions. First, how do we partition functionality into components that have clearly defined roles? And second, where does each of those components physically exist within the system? This architectural map is systematically built using 4 core steps. Step 1 is information selection, literally identifying exactly what data you need. Step 2 is compilation, merging those distinct pieces of info into a single cohesive view. Step 3 is information processing, actually crunching the analytical data or running the rules. And finally, step 4 is system interaction, handling any necessary communications with external systems to get the job done. Section 4, demystifying MVC architecture. So, MVC, it's the ultimate paradigm for splitting up concerns. MVC stands for Model View Controller, and it ensures your data, your user interface, and your control logic don't just turn into a massive tangled mess of spaghetti code. By separating the app into these 3 logical components, the whole system becomes structured, predictable, and highly efficient. Honestly, think of the MVC cycle like a busy restaurant. The controller? That's your traffic cop waiter. Taking your order from the browser, it manages your request and decides what should happen next. The model is the kitchen. It encapsulates all the application's business rules, connects to the database pantry, preps the ingredients, and holds the data. And finally, the view is the beautifully plated food brought back to your table. It takes the data processed by the model, formats it, and constructs the actual output you see on your screen. So why do we actually use MVC? Well, it all comes down to the separation of concerns, keeping your data and your UI completely independent. This gives you massive maintainability. because you can isolate and debug issues easily. It enables reusability, meaning you can hook up the exact same model to completely different views, like a web browser versus a mobile app. And perhaps most importantly, it allows for incredible scalability and parallel development, letting huge teams build complex systems efficiently at the exact same time. Section 5. Mapping System States. Okay, let's talk about state modeling. This basically tracks the actual motion of a user's journey. It outlines exactly how a system reacts to specific events, how it processes rules, and how it transitions from one functional behavior to another based on what the user does. It is essentially the roadmap of the app's logic. Take a look at the flow in an online shopping state diagram. When you move from add to shopping cart to checkout, you aren't just magically jumping between screens. You are triggering highly precise, predefined state changes. Every single action is intercepted by the controller, handed off to the model to update the system state, and then passed to the view to show you the next step. It's a perfectly choreographed dance, completely managed by the underlying functional architecture. Which leaves us with a final question to ponder. The next time you open up your favorite web app, can you spot the invisible architecture, the digital waiters, and the complex state transitions working tirelessly just beneath the surface to make it all feel like magic? Thanks so much for joining me on this explainer, and keep looking beyond the screen.